Good morning, everybody. So for this activity, we're going to use the 4-door foldable. So make sure you've made one. The other thing you're going to need is 5 different colored pencils. And this time you don't get your pick. You're going to have a blue one, but the shade doesn't matter, an orange, a green, a purple, and a red. So any shade of those colors is what you're going to need for this activity and what you're going to need to have in front of you. So with pencil, the first thing we're going to do is at the top, write down that this foldable is going to help us summarize the 4 pieces of evidence for evolution. How do scientists know that it has happened, that animals and plants have changed through time? And this comes from chapter 6, section 2 in our books. So with blue, we'll start with blue, number 1. The first piece of information comes from fossils. And so what I'm going to have you do when this video is over, right here, you're going to draw a picture of fossils. So I'm going to write down very lightly, so I can erase it, picture of fossils. You don't need to write this down. This is just a reminder for you. Picture of a fossil goes here. So you're going to be able to be artistic in a few moments. So we're going to open up this door, and in this we're going to write down a summary of how scientists use fossils to indicate that animals have changed through time. So fossils show the structure of organisms that lived in the past. And here's the definition of something called the fossil record. The fossil record is made up of millions of fossils that have been collected throughout the years. The fossil record shows how and when new species evolved, and how they're related. So when a scientist finds a fossil, they obviously can see the shape of the bones that made the fossil, and by determining where in the rock level it was discovered, they can date the fossils to a certain age. How old is this fossil? So they have an idea of when that particular organism was here on the earth. The second piece of information, and let's go ahead and use orange for this, is early development. And we're going to start off right away with an example. For example, the chicken, fish, turtle, and pig. What about them? Well, in early development, all 4 have a tail, and they also have slits along their throats. The idea here is that, and we know many of these organisms don't have a tail any longer as after they're born, and so why do all of these creatures have tails and slits when they don't have those anymore? The idea, after they're born, the idea is that there's a common ancestor passing down these genes that these animals, different animals, are getting. Okay? So that would suggest that through time, these animals obviously have changed. A chicken, a fish, turtle, and pig are very different from one another, but yet there's a lot of similarities in their early development prior to being born. So we're going to leave this right here for a picture of early development, and you're probably trying to figure out what kind of picture you're going to draw. You might consult your book for Chapter 6, Section 2 to get some ideas of that. All right, so let's go now to our third piece of information, and let's go ahead and use green for that. Our third piece of information that suggests that animals have changed through time is body structure. And the definition of this is how bones are arranged. And this is a vocab word, so we're going to use our red to highlight this. Okay, and let's go back to the number 1. I forgot to tell you this. What we're going to do here is we're going to highlight fossil record because that also is a vocab word. So fossil record and body structure. Okay, so for body structure, let's open up our door, and we're going to also start off with an example. For example, fish, reptiles, amphibians, birds, and mammals all have an internal structure, an internal skeleton with a backbone, this would suggest, right, fish with a backbone, birds with a backbone, reptiles, amphibians, this suggests that they had a common ancestor because remember, the reason they have a backbone is because they inherited genes that said they were going to have a backbone. So, you know, through time now, these animals obviously are very different from one another. So they're very different, but yet they all have these similarities with their skeletal system. Well, there must be some kind of a common ancestor passing down these genes through generations of time. Okay, and then let's write down the definition of something called a homologous structure. Okay, this is a similar structure and the idea is that it came from a common ancestor. So keep in mind here that you may not have read about this yet in Chapter 6, Section 2, or been exposed to any other information on Chapter 6, Section 2 yet. That's okay. This is still going to be the summary for that. That's what the purpose of this foldable is. So your teacher may or may not have, at this point, have given you any other information on 6.2. So if any of this is foggy to you, that's okay. You're going to be getting that information. And then this will make more sense. Remember, this is just a summary. So let's do another for example here. The wing of a bird, the flipper of a fish, particularly a dolphin, and the leg of a dog are all homologous structures. Why? Because they're similar structures. They perform some of the same tasks. They're made up of the same bones. You'll be seeing pictures of that. And so how did a bird, a fish, and a dog all get the same kind of a forearm? And so that's the homologous structure here. It's the forearm that is very, very similar. Well, the idea is that they got the genes, but from some common ancestor from millions of years ago. So we're also going to highlight this with red, okay, because that's a vocab word. And then the last color we're going to use is purple for our fourth piece of information, evidence for evolution. And this comes from similarities with DNA and protein. Now, you guys have all talked about protein, I think, in health class, so you're kind of familiar with that. Protein is a molecule, and it's found in our bodies, and it's necessary for growth, and primarily found in meats is where we get a lot of protein from, and eggs. So DNA is an abbreviation that stands for a really big word that is called deoxyribonucleic acid. And DNA is just short for that. DNA is also a protein, made up of protein. DNA is found on the genes that get passed down from parents to offspring. We talked about that with our dog breeding activity. So those genes are made up of DNA, and DNA is made up of protein. Okay, we're going to be doing a lot more work with that. So we do want you to know that. So let's open up our flap here and write down that genes control body structure. Well, and genes control everything about us. They control everything about what traits we have. We know that. And development. So our genes are in total charge of our development, what we end up with as far as traits are concerned. Since this is similar in some organisms, the idea is there might be a common ancestor. Millions of years ago, and throughout the years has been passing down the genes as they have been reproducing. I didn't mean to write there, I meant to write the. So let me see if I can't erase the R and the E. Yeah. The more similar the DNA, the idea is the more closely related are the species. Very much so. I mean, I think we'd all agree that while, say dogs and elephants are very different from one another, they're more alike than a dog and an insect. So, and it just so happens that the dog and the elephant DNA is very similar. So, but very different as well. But it's even more different with a dog and a bug and an insect. So the idea is then, so how do animals end up having a whole lot of similarities, but yet there's some differences too? Well, the more closely the DNA, and obviously where did DNA come from? It's found in the genes that are passed on from the parents to the offspring. So go ahead and draw a picture now of each one of these. Again, if you're kind of in a fog on how to do that, you might want to just look in your book in Chapter 6, Section 2.